Okay, today we're going to talk about some things. I'll lead off with the question is, why can balloons fly and boats float? Why do balloons fly and boats float? Because it's all about density. The hot air in a balloon, or helium in a balloon, is less dense than the air, so it floats up. So this balloon, usually with hot air balloons, there's a fire source here, and it's going to heat up the air inside the balloon. That balloon, the air in the balloon becomes less dense, and it rises because it is less dense than the air around it. You throw a rock into a pool, the rock is going to sink because the rock is more dense than the water that it goes in. So it's all about density. More dense things are going to rise, more dense things are going to sink, less dense things are going to rise. I would like you to write this down. Density is kind of our heading today. Density is the calculation of the amount of matter in a particular space. Density is the calculation of the amount of matter in a particular space. When you look at the two boxes there, okay, the boxes take up the same amount of space, but the one on the left is more dense, meaning the atoms in that are jammed together. The one on the right, it's still taking up the same amount of space, but it's spread out. So the one on the left is more dense than the one on the right. There's like a little joke riddle thing that I've heard where you try to get someone to say something dumb. You say, oh, what weighs more, a pound of rocks or a pound of feathers? Okay, well, most people say rocks. But what happens is a rock is just more dense. A 1 pound rock isn't very big. A pound of feathers would take up a big area because feathers are light and not very dense. Another thing that you commonly see is another one, muscle and fat. Okay, muscle is a highly dense tissue, meaning 1 pound of muscle is going to not be much bigger than maybe your pencil, maybe a little wider, but that's 1 pound of muscle. A pound of fat is going to be much less dense, so it's going to look like more. Okay, some of you guys who have some muscles, you weigh more than most people would guess because your muscle is very dense and it's weighing you down. So density, how much space you're taking up. Write this down. Density equals mass divided by volume, or mass divided by volume equals density. So mass is how much it weighs, or how much gravity is pulling down on it. Volume is how much space it takes up. It might be in gallons, it might be in cubic inches, centimeters, whatever. So density equals mass divided by volume. We're going to have a density lab on Monday where we measure the density of certain things. Don't need to write anything but some density of some common substances. So water, pure water, its density is 1 gram per centimeter cubed. That means 1 cubic centimeter of water weighs 1 gram. If you are more dense than that, you're going to sink. Less, you're going to float. So ice, frozen water, is 0.92 grams per cubic centimeter. Okay, so that is less than 1.0. So that means ice, when you put it in water, is going to float. Okay, you put ice in your water to cool it off, or your pop or whatever, it's going to float to the top. Butter, 0.9 grams per centimeter cubed. So if you put a stick of butter in your glass of water, the butter would float. Gold, 19.3 grams per centimeter cubed. That's going to float right to the bottom. Maybe watch some of those shows like where they're panning for gold in the creeks and stuff. They usually scoop stuff out of the bottom of the stream or the creek because that's where the gold would be because it's super dense. Gasoline, 0.8 grams per centimeter cubed. That would float on the top of water if I mixed them. Vegetable oil, 0.9, so that would float. Seawater. Seawater is water with salt in it, 1.03. So salty water is more dense. So you're going to find, like in the ocean, the deeper you go, the saltier it's going to get because salt makes that water heavier. The surface water will be the least salty of all the ocean water. And then vinegar, 1.01. Vinegar is mostly water. Okay, so just some things to kind of look at. Air. So the air in this room is about 1.3 grams per cubic centimeter. So helium, 0.18. That's why you fill up a balloon with helium. It shoots right up because look how less dense it is than the air around it. Nitrogen, 1.25, so that's less dense than the air around it. Oxygen is heavy, 1.43. I don't know if you guys had like fire safety class or something when you were in elementary, but one of the things they tell you to do is if there is a fire and the smoke is bad and everything, you should crawl on the floor for 2 reasons. One, because the smoke rises, so you'll be under the smoke. But 2, the oxygen is dense. So the oxygen, there's going to be most oxygen down close to the floor. So if you crawl on the floor, you'll stay out of the smoke and you should be able to breathe. And then hydrogen, 0.09, super light, not very dense. The only reason we don't use that more is because it's really flammable. Why do baseballs fly further at higher elevation? Less air molecules. The air is less dense the higher you go up. So Denver is known as the Mile High City. Okay, well if you're a mile in the air, there are less air molecules. The gravity is pulling on less air molecules. So if I hit a baseball playing for the Colorado Rockies, okay, and it barely gets over the fence for a home run, if I am in New York where it's sea level, it's not even close to a home run. Because the one in New York is hitting more air molecules, it's slowing down much faster than the one in Denver. So if you're a baseball person, if there's ever a Colorado Rockies player that's in contention for like the MVP or something, they always say, well, he plays in Denver where the air is thin. He wouldn't have all these hits if he played somewhere else. With football, I believe like 3 of the 4 longest field goals ever happened in Denver because you can kick it further in the light air. It hits less air molecules, it slows down less. So higher elevation means less dense air. Okay, just something to kind of look at here. A solid, liquid, and a gas. It's the same amount of matter, and you see the solid is going to hold its shape and it's not going to expand or contract much. The liquid, it's going to take the shape of the container that it's in, and then a gas is going to spread out in its entire container. So the air in this room could be compressed into like a gallon milk jug. You could just jam all the molecules close together, okay? But they want to expand, they want to spread out. This is what the molecules look like in a gas. If you look to the left, the little atoms are bumping into each other, moving a lot. With a liquid, it's kind of like a ball pit moving there. And then a solid, they're moving together very faintly, very little. All right, there we go.